Okay, so firstly, when I do Fourier series, I like to draw a graph first so that I can visualize whether this is an odd function or even function. Okay, so when we draw a graph, we just plot the x-axis and y-axis accordingly. So we have this t on the x-axis and ft on the y-axis. Next, there are three portions to draw. T plus 2 from minus 2 to minus 1. So your x-axis, you just label minus 2 to minus 1. Then you draw a t plus 2 over here. You'll notice that t plus 2 is just a t term. You expect only a straight line. For a straight line, you just draw a straight line. You don't need to draw anything curve. You substitute the minus 2 inside here, what you get? You get 0. Put the x there. Substitute the minus 1 to this equation, you get a 1. So you draw over here. Then you just connect these 2 points using a straight line. So that's it. How about 0? 0 equals from minus 1 all the way to 1. You label a 1 over here, then you draw 0. That's it. And t minus 2 equals from 1 all the way to 2. You substitute the 1 into this equation, you get minus 1. Draw minus 1. Then you substitute 2 inside this equation, you get 0. So that's how you draw the graph. So this is the graph that you will need to draw during your exam. Preferably, you will need to draw all the graph so that you can visualize. From here, how do we know that this is an odd or even function? What I usually teach is you fold along the y-axis first. Once you fold along the y-axis, you know that this line will match, but this two line doesn't match. But what happens if you fold along the x-axis? You'll notice that the lines will all be overlapped together. If you're not sure, you write on a piece of paper, then you fold them. You fold it 2 times. First time on the y-axis, second time on the x-axis. Once you notice that these are together, you know that this is an odd function. You fold along the y-axis, then it matches is an even function. So over here, this is an odd function. So knowing this is important so that it can help you to simplify your equation. Okay, so from here, odd function. All you have to do is to calculate all these things that are already given in your formula sheet, A0, AN, BN, and your FT eventually. So we do it one step at one time. E0 first. A0, we can write down, A0 equals to 1 over t. Then it goes from minus 2 all the way to 2. Ft dt. There's a property that we know from all functions. For all functions, this integral will be 0. Why is it 0? You see that there's a small area over here, and this area will be equals to this area. So this positive area will cancel off the negative area, you get 0. So your A0 will be 0, and that's the property of an odd function. So that's the first part. Second part, you need to find AN. You can write down the equation, 2 over t. Over here, you'll notice that you have an odd function that is going to be multiplied by a cosine function. You can quickly sketch out a cosine function, and you'll know cosine function is odd or even. So quickly sketching out a cosine function. cosine function is an even function. So you have an odd function multiplied by an even function. What I taught in class last time, you need to know odd function multiplied by even function equals to what function. This is equivalent to your XOR gate, where you have odd, even, and then it gives you back. So this is also an odd function. Odd function, you also get a 0. So you can just simply write equals to 0. So this will simplify your steps a lot. Lastly, you need to find your Bn. Your Bn, you copy the equation over 2 over t. It goes from -2 all the way to 2. Then ft sin n omega naught t dt. You'll notice that one period over here, this is 4, it goes from -2 to 2, therefore t equals to 4. Ft is an odd function, and sin t is also an odd function. So odd times odd, what do you get? Again, you can recall from Boolean algebra. For XOR gate, odd times odd will give you an even function. So we'll keep it as it is first, but we can do some tricks to manipulate your odd times odd. So since this is an even function, we can multiply 2 on the outside. We change this to 4. After that, we change the lower limit of the integration to 0. And then we keep the upper limit. We keep this the same. So why is this so? You'll notice that for a even function, whatever thing on the left side of the x-axis is equals to whatever thing on the right hand side of the y-axis. So you can essentially just integrate one part, which is essentially integrating from here all the way to here. So that's the trick that I'm using. It's to simplify your equation.
How do you get 4 on your numerical?
How do I get
4.
Okay, so this 4, right, is 2 multiplied by 2.
Why do you multiply by 2?
Okay, so why do I multiply by 2? If I have an even function, for example, a cosine function that's even, so this is an even function. If I am integrating one period, let's say from here all the way to here, this is one period, right? So this is the area over here that I am trying to find. Essentially, it's the same as integrating from here to here. Just like I need to multiply by 2. Yeah. Okay, so right now I have 4 over 4 which I can cancel off. How do I do with this ft over here? Ft is defined in this manner. I have 0 to 2 over here. So 0 to 2, it includes this portion, 0, and it includes this portion, t minus 2. So one question I ask myself is, what happens if I multiply a function by 0? What do I get? 0. So do I have to care about this portion? I don't have to care about this portion. I just have to care about this portion, 1 all the way to 2. So I can change the integral limit again, because I don't have to care about this portion. Agree? So let's change the integral limit from 1 to 2. Now ft is defined as t minus 2, between 1 and 2. So over here I have t minus 2 sine n omega naught t dt. Okay, so clear so far? This omega naught is actually this 2 pi over t. T is 4 because there's one period. So we have pi over 2 as omega naught. You can just write pi over 2 over here. Next, you have to do with this integration. T minus 2 bracket sine of this thing. You can break up this, means t sine n pi over 2 t dt minus 2 sine of this. You can either break it up or you can just use the di method to solve your integration by parts. You can write on one side and solve the integration by parts. What you have to differentiate is t minus 2. Then what you have to integrate will be sine n pi over 2 t. Agree with this? So you differentiate this all the way up to 0. T minus 2, you keep differentiating, you get 1 and then 0. This one you will need to keep integrating. So sine will become negative cosine then this one you integrate it. After that, no arrow, then plus minus. So this integration will be equals to t minus 2 minus 2 cosine n pi t over 2 over n pi minus will become plus 4 sine n pi t over 2 over n pi square. This whole thing t equals to 2, t equals to 1. After that, you can substitute in the values accordingly. From here, your t equals to 2, you substitute here, your first term will become 0. Second term, t equals to 2, you substitute here. For sine n pi over n pi squared. Minus, substitute t equals to 1 over here. This term will become minus 1. Minus 1 multiplied by minus 2, it will be 2. Cos n pi over 2 over n pi. Substitute 1 over here. Over here, there's another thing that you can cancel off, which is the sine n pi term over here. Again, if you're not sure, you can sketch out the graph quickly and you can determine what is sine n pi. So this is your sine curve. Then over here is 0, here is pi, 2 pi, 3 pi, 4 pi, and so on. So sine n pi, whenever n is an integer, sine pi is 0, sine 2 pi is 0, sine 3 pi is 0, sine 4 pi is also 0. So this sine n pi will also be 0. You can cancel this off. Don't need to do this, you just need to do the other two terms behind. But the two terms behind looks like we can't simplify them much. So we can leave it as it is because it's n pi over 2. So Bn will be equals to 2 cos n pi over 2 over n pi plus 4 sine n pi over 2 over n pi squared. So that's your answer. Last week, we just need to place all of them together so that we can find the Fourier series. The Fourier series is defined as ft equals to a naught. A naught we know is 0, and all your an terms is 0. So this sigma over here will be 0. You just have to deal with the second summation. How to deal with this? You let n equals to 1, n equals to 2, n equals to 3. So when n equals to 1, what is this terms over here? You substitute n equals to 1, you get 2 cosine pi over 2. And cosine pi over 2, we know is 0. So we don't have to do with anything here. Then sine n pi over 2. Sine pi over 2 is equals to 1. So you have 4 over pi squared. So that's your first term. Then next you let n equals to 2. You have 2 cosine pi. 2 cosine pi is 1. 1 over pi. Then this term over here, sine pi is equals to 0, so you don't have to do with this. Lastly, you substitute n equals to 3. When you put n equals to 3 over here, you get cosine 3 pi over 2, which is also equals to 0. So you need to do with this term over here. And sine 3 pi over 2 is minus 1. So this should be your answer.